Good morning, my dear student friends. In this topic, I shall discuss about the active filters using operational amplifiers, right? And basically, I will confine my discussion on the second order filters. Of course, I will tell you about what are the second order filters. The entire presentation I have split into five smaller parts in order to make the things easier for the purpose of understanding. So the first part will be the introductory part, followed by the discussions on the low pass filter, high pass filter, band pass filter, and band elimination filter. Right. So now let us move on to the first part, that is the introduction. Right. Let us see what are the various aspects related to the active filters. Um, First of all, we will have to have the definition, right? What are filters? What do you mean by filters? So the literal meaning of the filters everyone knows, right? To filter something. So electronically speaking, it is basically a frequency selective circuit which is used to allow the signals of only certain frequency to pass through it. And when we say that, when we are using it to make the signals of only certain frequency to pass through it, it has got a lot of practical relevance. No, if you think of some communication circuits, right, wherein you want to send or pass only certain signals of specific frequencies and reject the other signals, or block the other signals, there you generally find a lot of applications of the filter. But definitely the applications are not limited to only communication circuits. It can be used in many of the electronic circuitries, right? Over the period of time, we will see where exactly these filter circuits are used, right? Now I have already told you there where they are used also, right? In the communication circuits, even in the instrumentation applications, even in the biomedical applications, there these filter circuits are used. Now let us come to the next point, which is very important here. What are the different types of the filters, right? When we speak about the types of the filter, when we speak about the types of the filter, there are different attributes based on which these types of the filters can be had. The very first one, depending upon what kind of components you are making use of. So that gives us the two categories. One is called as the active filter and another is called as the passive filter. Anyway, the active filters and passive filters I will discuss. But before that, let us try to see what are the other categories of the filters you have. Now, based on the order of the filter, right? Order of the filter. I have already spoken about the second order filter in the previous slide. Now, the order of the filter means whenever the filter is blocking certain frequencies or certain signals of some frequency range, right? How sharply it is going to block those signals, that is decided by the order. Actually speaking, your diagram here should look like this. So now if these frequencies, I mean these signals of these frequencies are passed, then immediately it should be able to block it like this, right? That doesn't happen because of the physical limitations, right? So now this blocking, either it might take place like this, or it might take place like this, or it may take place like this. That is decided by the order of the filter, right? So it is basically, this particular phenomena is called as roll down. This phenomena is called as the roll down, and the order of this roll down usually will be in the form of minus 20 dB per decade. You must be knowing about what is the meaning of this, right? So if the roll off takes place at the order of minus 20 dB per decade, then we call it as the first order filter. If it takes place at the order of minus 40 dB per decade, then it is called as second order filter. If it is taking place at minus 60 dB per decade, then it is called as third order filter, so on and so forth, right? Generally, we won't go beyond the third order filter, though theoretically you can go to any n order filter, right? And what exactly is this role of, how exactly it decides the performance of the filter, all those things we shall see in our subsequent slides. But the difference, or the types based on the role of, is referred to as the order of the filter. That is the first order filter, second order filter, third order filter, so on and so forth, right? Then you have one more category, that is based on the frequency range of attenuation or passing, right? So there we have, as I have already told you in the previous slide, right? We have got the low pass filter, then we have got the high pass filter, then we have got band pass filter, right? And we have also got band elimination filter, which is also referred to as the notch filter, right? So now each of these things, anyway, we will be able to discuss in a elaborative manner later. I am not going into those details right in this particular slide, right? Then depending upon the very frequency response, you know what is the meaning of frequency response? If you plot the gain against the frequency, whatever the curve we are going to get here, right? So that is said to be the frequency response. Now, depending upon the frequency response, we have got the different kind of filters which are referred to as the Butterworth's filter, a Chebyshev's filter, Bessel's filter, elliptical filter, and all, right? So now, basically here in this particular discussion, we will confine ourselves to the Butterworth's filter, where in the Butterworth's filter you have the flattest pass band, right? Pass band in the sense this portion, right? So as long as your pass band is the flattest, then you call it as the Butterworth filter, right? So in different filters you have got different kinds of the pass band. It may be like this, or it may be like this, something like that. That all, again, further makes the classification in terms of the other types which I have just mentioned. It is maybe Chebyshev's filter, Bessel's filter, or elliptical filter, something like that, right? Now, in our discussion here, right, we shall basically confine our discussion to the second order, right, Butterworth filter. Whatever we are going to discuss here is going to be the second order Butterworth filter, right? Now with that, we will come to the next point there, the difference between the active and passive filter. So this is again a very important point to be noted, right? So as long as the passive filters are concerned, you have the passive components, used for the design of the filter, right? Again, the resistance, inductance, and capacitance. Generally, in the passive filter, right, you see you don't give any input, and the gain is always less than 1, so your output V naught will be always less than V in, and we have got a lot of practical limitations in order to implement the passive filters, as long as the order of the filter becomes higher and higher, though it is simple in design compared to the active filters, right? But they are limited to lower orders. If you want to go with the higher orders, then it will be always difficult to realize the actual desired performance in the passive filters, right? Now, let us not go into much details about the passive filters. We will try to restrict ourselves to the active filters. So whenever I say about the active filter, the active components are involved. So it may be your transistors, or it may be your FET devices, or it may be your op amps, right? Op amp devices. So whenever the active devices are involved, you always have the advantages of the performance compared to the passive filters, right? Now, here we basically discuss about the active filters, and very specifically we discuss about the filters which are designed using the operational amplifiers. Now the very question is, why operational amplifier based filters, right? You have got the other counterparts also in the active filters. Now since we are discussing about the operational amplifier based filters, let us try to see some of the basic advantages of using the operational amplifier based filters. The first thing is that, as the name itself indicates, you have the possibility or you have the provision of amplifying the signal along with the filtering. Then low noise, right? As far as the operational amplifiers are concerned, we have already seen some of the inherent advantages, features of the operational amplifier. Low noise, right? You have very less attenuation in the operational amplifiers, right? You have selective outputs, right? You have the selective outputs. Then bandwidth adjustment is possible, right? And the performance characteristics are very much acceptable here in the operational amplifiers, right? You have got a very high input impedance that makes your entire circuit to draw as less input as possible, right? And the second thing is that since the low output impedance of your operational amplifiers make the characteristics or the cutoff point. What I mean by the cutoff point is here, this particular point, the cutoff point. This cutoff point is almost going to remain stable if you make use of the operational amplifier, right? So these are some of the advantages of going with the operational amplifiers, and in our subsequent slides we shall see what exactly is the advantage, typical advantage of going for the operational amplifier, right? Now let me basically introduce you to the types of the filters which we are going to discuss. So now if you look at this particular diagram, right? So the first column indicates the type of the filter. We start with the low pass filter. Please observe these columns carefully. In the second column, right, we have the input signal, and in the third column we have the output signal, and in the last column, right, we have the frequency response here. Okay. Now, as I've already told you earlier, the frequency response is basically the variation of the gain with respect to the frequency, right? Now coming to the low pass filter, as the name itself indicates, in the low pass filters, the signals of lower frequency or lesser frequency are going to be passed, and the signals of the higher frequency are going to be attenuated, right? Or they are going to be stopped. Now if you look at the second column here where you have got the input, right, I have got a signal Vs here, definitely in compared to Vn here, right? So the frequency of Vs is very low, and the very Vs is also superimposed with a signal Vn, which is of high frequency. Now if you apply this frequency, I mean this signal to a low pass filter, right, then you are going to get the output something like this, wherein only the signal with lower frequency will be passed with a little attenuation. Definitely there will be some attenuation depending upon the physical characteristics of the operational amplifier and associated circuits that you are using, right? So assuming that the attenuation is very less and negligible, you will be able to get the signal of the lower frequency which was there in the input at the output. And accordingly here in the fourth column where you have got the frequency response, right? So you have this particular range as the pass band, right, where this indicates the range of the frequencies of the signal which are going to be passed through the filter, and the other one beyond that, it is called the attenuation band, right? These are the signals which are not going to be passed because they are above a certain frequency which is called the cutoff frequency, that is Fc here, right? So now we are getting a characteristic something like this, right? And this is the point corresponding to gain equal to 1. Then here you have got say a minus 3 dB point, right, which is a 3 dB less gain point, and corresponding to that whatever we are having here, this is the cutoff frequency, right? The cutoff frequency differentiates or it draws the line between the pass band and the stop band. And now ideally speaking we would have wanted to have the frequency response something like this, which is not possible depending upon the order of the filter. Now we shall see how what is the meaning of this particular roll off in our subsequent slides, but before that we will try to see the operation of the other counterparts of the filter compared to the low pass filter. Now coming to, once if you have understood the working principle of the low pass filter, right, so then it is relatively very easy for us to understand the other types of the filters also. Now let me look at the high pass filter here. In the high pass filter, exactly the reverse phenomena what has happened in the low pass filter that takes place. Similarly, you have got the two signals here. One is of a lower frequency signal Vs, another is of the higher frequency signal, and when they pass through the filter here, high pass filter, right, so you will have only the signal of the high frequency passed through it, and you can see in the the frequency response curve, the first part is going to be the attenuation band, because the lower frequency signals are going to be stopped here and the upper or the higher frequency signals are going to be passed beyond fc, right, the cutoff frequency. So now these two are converse to each other, the low pass filter as well as the high pass filter, right. Now coming to the third one, that is the band pass filter, right. In the band pass filter, your frequency response would be something like this. Your frequency response would be something like this. It is going to be like this, right. So here you will be able to pass a band of the frequency. Let me call this as f1 and f2, as you can see here, fc1 and fc2, and that necessitates three input kind of signals to be present here. One is Vs as usual, low frequency. Another is V1 here, right, or V3 we have taken here, V3 of low frequency, V1 of very high frequency, and V2 of the frequency between V1 and V3. And your output here will contain the signals corresponding to the range of V2, what you can see in the the frequency response curve, right. So now this is going to be the pass band. That means here the signals between the frequencies fc1 and fc2 are going to be passed, and on either side of this pass band you will be having the stop band or the attenuation band. So this is the working of or this is the concept of the band pass filter, right. And the last one is called as the band elimination filter, which is also referred to as the notch filter. So again, in the band elimination filter, we have V1, we have V2, we have V3, as we have seen in the case of the band pass filter. But very importantly here, in the band elimination filter, right, you would have the frequency response something like this. You can see something like this. Now this is going to be your stop band, and this will be a pass band. This is also going to be the pass band. Only this frequency range signals or signals of this particular frequency range, they are eliminated or they are stopped from reaching the output, right. So therefore you have these frequency signals also passed, these frequency signals are also passed, and this is going to be blocked here, and accordingly you have the stop band here. This is going to be the pass band, and this is going to be the pass band. This is the simple concept behind the four types of the filters, right. And if you now look at the order of the filters, we have already spoken about this, right. So that's why I have taken it once again. If you want to have the frequency response exactly like this, where this particular slope is infinity, that is called as the ideal response, right, ideal response. But generally we have the frequency response something like this. If I take the frequency response of a low pass filter, and this is called roll off, this phenomena is called roll off, and at what rate this roll off takes place, that decides the order of the filter. If this attenuation or this roll off is at minus 20 dB per decade, then it is called as the first order. minus 40 dB per decade, as I already told you earlier, then it is the second order. If it is minus 60 dB per decade, it's the third order. That basically, as your order increases, basically the sharpness of this roll off, right? So that is going to change. The sharpness is going to change. So that means the performance of the system becomes better and better if the order is increased, right? But at the same time, you have to always keep in mind that as you increase the order, the complexity of the filter physical nature also increases, right? So you will have to have some optimum kind of the filters here, depending upon our requirement, right? So if you go with a fourth order filter, fifth order filter, you may get a extraordinarily good characteristics, but at the cost of very complicated hardware, right? So that should be always kept at the back of the mind, right? So with this, we have taken some of the basic introduction about the filters. What are filters, right? So what are the classification of the filters? What is the difference between the active filters and passive filters, right? Then also what is the meaning of the order of the filters, right? So in our next session, right, we shall come up with the the low pass filter, again the Butterworth, right? The second order filter, right? Second order, it will remain common for all the discussions, right? Butterworth second order filter, but the low pass filter, high pass filter, band pass filter, and band elimination filter, right?